Hi everyone, welcome to the Cosmic Space Channel. Tonight, we'll journey through the deepest mysteries of the universe. If you're ready, let's begin. Space. It is so vast that even with billions of stars scattered across the universe, darkness still rules almost everything. Many of those stars are larger than our own Sun. Yet between them lie immense regions where light barely reaches. Endless cosmic valleys stretching across unimaginable distances. Could these silent regions be hiding worlds we have never seen? Could they be protecting the universe's greatest secrets? No one knows. Perhaps one day humanity will find the answer. Today, even if we could travel at the speed of light, reaching many of these distant places would still take thousands of years. With the technology we possess today, such a journey would require millions of years. Will humanity ever reach those dark valleys? Will we ever discover what truly exists beyond the familiar stars? Only time will answer. For now, we know one thing. The universe is far from empty. Countless asteroids drift silently through space. Lonely planets wander without a parent star. Brilliant stars continue shining for billions of years. Frozen comets travel through the darkness, following paths that began long before Earth itself existed. Some move faster than a bullet. Others are as large as entire worlds. Could one of them one day alter its course and begin an unstoppable journey toward Earth? No one can say for certain. The universe has surprised us before. It may do so again. As our journey continues, we arrive at another remarkable family of celestial objects. Natural satellites. Almost every major planet in our solar system is accompanied by its own collection of moons. Each one follows a perfectly balanced orbit shaped by gravity. For billions of years, this silent dance has continued without interruption. The universe maintains an extraordinary balance. A balance so precise that even the smallest disturbance could reshape an entire planetary system. A natural satellite is a celestial body that orbits a planet or another larger object under the influence of gravity. Unlike the artificial satellites built by humanity, these worlds formed naturally during the birth of planetary systems. Earth has only one natural satellite, the Moon. Yet throughout the solar system, hundreds of moons circle giant planets in complete silence. Something many people never realize is that a moon does not simply orbit its planet. In reality, both bodies orbit a shared center of mass. Because the planet is much more massive, that point usually lies deep inside the planet itself. From Earth, it appears as though only the Moon is moving. But in truth, both worlds are constantly moving together. If two orbiting bodies have similar masses, astronomers no longer describe one as the moon of the other. Instead, they become a binary system. Two worlds forever bound together by gravity. Today, scientists have discovered more than 200 natural satellites within our solar system. Most belong to the giant planets. Others orbit dwarf planets and smaller bodies scattered throughout space. Beyond our solar system, countless more almost certainly exist. Some may orbit planets unlike anything humanity has ever imagined. Our journey begins with the closest companion Earth has ever known. The Moon. The Moon has been Earth's constant companion for more than 4 billion years. It is our closest neighbor in space. Located an average distance of 384,400 kilometers away, no other world has influenced our planet more profoundly. Because of its proximity, the Moon has become the celestial body we understand better than any other after Earth itself. Yet despite being so familiar, it still holds remarkable secrets. At first glance, the Moon appears simple. A silent gray world covered with craters. A place where nothing ever changes. But appearances can be deceiving. Many people believe the Moon has a permanent dark side. It does not. Every part of its surface receives sunlight. The reason we always see the same face is something called tidal locking. The Moon rotates once on its own axis in exactly the same amount of time it takes to complete one orbit around Earth. As a result, one hemisphere always faces our planet, while the opposite side remained hidden from human eyes for thousands of years. The Moon does far more than illuminate our night sky. Its gravity constantly pulls on Earth's oceans. As our planet rotates, enormous bulges of water slowly travel around the globe. These movements create the tides that shape coastlines across the world every single day. Without the Moon, Earth's oceans would behave very differently. Even today, the Moon continues changing. Every year, it drifts about 3.8 centimeters farther away from Earth. It may seem insignificant, but over billions of years, even such tiny movements become extraordinary. Scientists estimate that this gradual separation will continue for tens of billions of years. One day, a complete orbit around Earth will take much longer than it does today. Unlike Earth, the Moon has almost no atmosphere. Nothing protects its surface from meteorites. Nothing shields it from the harsh radiation of space. The solar wind strikes it directly. Tiny impacts continue shaping its landscape. As a result, its surface is covered with countless impact craters formed over billions of years. The absence of an atmosphere creates another strange reality. The sky above the Moon is always black. Even during the lunar day. There is no blue sky. No clouds. No wind. No sound. Only silence. Many people imagine the Moon as a lifeless world. Yet deep beneath its surface, it is not completely inactive. Moonquakes still occur. Some are triggered by Earth's gravity. Others originate from the Moon's own interior. Evidence even suggests that part of its core remains partially molten. The Moon may appear quiet, but deep inside, it has not become completely still. Although it is only the 5th largest natural satellite in the solar system, no other moon compares with it in one remarkable way. Relative to the size of its planet, Earth's moon is exceptionally large. Some scientists believe the Moon was once part of Earth itself. According to the giant impact hypothesis, a Mars-sized object collided with the young Earth billions of years ago. The enormous impact blasted huge amounts of material into orbit. Over time, that debris slowly came together, eventually forming the Moon. It remains the leading explanation for the Moon's origin. Yet, like many great mysteries of the universe, the complete story has not been fully uncovered. Our closest neighbor still has secrets waiting beneath its ancient surface. And our journey has only just begun. The next worlds awaiting us belong to the giant planets. Worlds surrounded by dozens of extraordinary moons, each one stranger than the last. Our journey now leaves Earth behind. Ahead of us waits the giant planets, each surrounded by a remarkable family of natural satellites. We begin with Saturn, the jewel of the solar system. Its magnificent rings have fascinated humanity ever since the first telescopes revealed their beauty. Orbiting as the sixth planet from the Sun, Saturn is the second largest planet in the solar system. Only Jupiter surpasses it in size. Despite its enormous scale, Saturn is made primarily of hydrogen and helium. It is a true gas giant, a world with no solid surface on which you could ever stand. Long before modern astronomy, Saturn was already visible to the naked eye. Ancient civilizations watched its slow movement across the heavens, never realizing they were observing one of the most extraordinary planets ever formed. Today we know that Saturn is accompanied by an astonishing collection of moons. Some are covered entirely in ice. Others hide oceans beneath frozen crusts. A few possess landscapes unlike anything found anywhere else in the solar system. Our first destination is one of the strangest among them. Mimas. Discovered in 1789 by William Herschel, Mimas measures only about 396 kilometers across. At first glance, it appears to be just another frozen moon, until you notice the enormous crater dominating almost its entire surface. Known as Herschel Crater, this colossal impact scar gives Mimas an unmistakable appearance. It resembles the fictional Death Star from Star Wars so closely that the comparison has become impossible to ignore. The impact that created this crater was unimaginably violent, powerful enough to nearly shatter the moon completely. Yet somehow, Mimas survived. Its fractured surface remains frozen in time, preserving evidence of one of the most dramatic collisions in solar system history. For decades, scientists believed Mimas was little more than a solid block of ancient ice, a cold and inactive world. But recent observations have raised an extraordinary possibility. Deep beneath its frozen shell, hidden from view, there may be a liquid ocean. If confirmed, Mimas would join a growing family of icy moons concealing vast oceans beneath seemingly lifeless surfaces. Researchers studying its subtle wobble notice movements that could not be explained by solid ice alone. The data suggested the presence of a hidden ocean buried between 24 and 30 kilometers beneath the surface. Such a discovery would completely transform our understanding of this tiny world. How could a moon so small retain enough internal heat to keep water in liquid form? No one has a definitive answer. Some scientists believe tidal forces generated by Saturn may still be warming its interior. Others continue searching for different explanations. For now, the mystery remains unsolved. Even a world that appears frozen and lifeless from afar may still be hiding something extraordinary beneath its surface. Mimas reminds us that appearances can be deceiving. Sometimes the smallest worlds preserve the greatest mysteries. And Saturn still has many more waiting for us. Our journey continues to another fascinating moon of Saturn, Epimetheus. At first glance, it appears to be nothing more than a small, irregular world drifting through the darkness. Its average diameter is only about 116 kilometers. Tiny compared to many of Saturn's larger moons. Yet its orbit makes it one of the most unusual objects in the solar system. Unlike any ordinary moon, Epimetheus shares its orbit with another satellite, Janus. Every 4 years, something extraordinary happens. As the two moons slowly approach one another, gravity begins to reshape their paths. Instead of colliding, they exchange orbits. One moves slightly closer to Saturn. The other drifts slightly farther away. Then they continue their endless journey until they meet again. It is the only known example of this remarkable orbital dance anywhere in the solar system. For billions of years, the two moons have repeated this graceful exchange without ever crashing into one another. A perfect demonstration of gravity working with astonishing precision. The surface of Epimetheus tells another story. Ancient impact craters cover almost every part of the moon, each one preserving a record of collisions that occurred over billions of years. Unlike larger worlds, Epimetheus does not possess enough gravity to pull itself into a perfect sphere. Instead, it remains irregular. Its rugged appearance revealing the chaotic conditions that existed during the birth of the solar system. Scientists still do not know exactly how Epimetheus formed. Perhaps it was created alongside Saturn itself. Or perhaps it was captured long after the giant planet had already taken shape. For now, its true origin remains uncertain. Every new observation reveals another small piece of the puzzle. As we leave Epimetheus behind, one thing becomes increasingly clear. Saturn is far more than a beautiful planet surrounded by rings. It is an entire system of mysterious worlds, each moon preserving its own chapter in the history of the solar system. And many of those chapters have yet to be fully understood. Our next destination takes us even farther into Saturn's remarkable family, toward another small moon whose story is just beginning to unfold. Beyond Mimas, Saturn's vast family of moons continues to surprise us. Our next destination is Narvi, a small and distant satellite discovered in 2003. Compared with Saturn's larger moons, Narvi has received very little attention. Even today, astronomers know surprisingly little about this mysterious world. It completes a single orbit around Saturn in nearly 956 Earth days, moving silently through the darkness, far beyond the planet's magnificent rings. Like many of Saturn's irregular moons, Narvi is believed to have been captured by Saturn's gravity long after the solar system formed. Rather than forming alongside the planet, it may have once traveled freely through space before becoming permanently trapped. If that idea is correct, Narvi is not truly Saturn's child. It is a traveler from somewhere else, waiting for humanity to uncover its past. As telescopes become more powerful and future space missions venture deeper into the outer solar system, worlds like Narvi may finally reveal their secrets. The universe constantly reminds us that every answer leads to another question. Every discovery opens another mystery. Some planets may be made almost entirely of diamond. Others could contain unimaginable quantities of precious metals. Some are frozen worlds where temperatures never rise above deadly extremes. Others are scorching infernos covered with oceans of molten rock. The diversity of the universe continues to exceed every expectation. And if planets can be so different from one another, imagine how extraordinary their moons might be. Our journey now brings us to another of Saturn's distant companions, Skathi. Small, dark, and almost invisible against the endless backdrop of space. Discovered in 2000, Skathi measures only a few kilometers across. Yet despite its tiny size, it follows a remarkable orbit around Saturn. Unlike the large regular moons that travel close to the planet, Skathi belongs to a distant family of irregular satellites. Its path is highly inclined. Its orbit is far from circular. Everything about its motion suggests that it was captured by Saturn's gravity billions of years ago. Rather than being born alongside the planet, Skathi may once have wandered freely through the solar system before being pulled into Saturn's gravitational embrace. Worlds like this rarely attract attention. Yet they preserve some of the oldest memories of the early solar system. Each one is a surviving fragment from an age when planets were still taking shape. And each one quietly waits for us to uncover its story. Our next stop takes us to another distant member of Saturn's remarkable family, Greip. Discovered in 2006, this tiny moon measures only about 6 kilometers across. It is one of the smallest known satellites orbiting Saturn. At such a small size, Greip is little more than a rugged fragment of rock and ice traveling through the darkness. Yet even a world this small has its own story to tell. It completes one orbit around Saturn in roughly 900 Earth days. Far beyond the giant planet's bright rings. Far beyond the familiar worlds that receive most of our attention. Like many of Saturn's irregular moons, Greip follows a highly tilted and elongated orbit. Its unusual path suggests that it did not form alongside Saturn. Instead, astronomers believe it was captured by the planet's immense gravity billions of years ago. A lonely traveler that wandered too close to the solar system's ring giant. As our understanding of Saturn continues to grow, one thing becomes increasingly clear. Its smallest moons may also be its oldest, each preserving ancient material from the earliest days of planetary formation. Each offering another glimpse into a time when the solar system was still taking shape. Leaving Greip behind, we now arrive at one of Saturn's most extraordinary moons, Janus. Unlike any other moon we have visited, Janus shares an orbit with Epimetheus. Together they perform one of the rarest gravitational dances known in astronomy. Every few years, the two moons slowly approach one another. Gravity begins to reshape their paths. Instead of colliding, they exchange orbits. Janus moves outward. Epimetheus moves inward. Then the endless cycle begins again. It is a breathtaking demonstration of celestial mechanics. One that has continued for billions of years without a single collision. Janus itself measures roughly 179 kilometers across. Its ancient surface is covered with enormous impact craters. Some stretch for more than 30 kilometers. Silent reminders of violent collisions that occurred during the solar system's earliest history. Like many of Saturn's smaller moons, Janus lacks the gravity needed to pull itself into a perfect sphere. Its irregular shape preserves the scars of its chaotic past. Every crater, every fractured ridge, every shadow across its surface tells part of a story that began billions of years ago. The farther we travel through Saturn's system, the more we realize something remarkable. No two moons are truly alike. Each one follows its own path. Each one has survived its own history. And each one continues its silent journey through the endless darkness of space. As we continue exploring Saturn's remarkable system, one truth becomes impossible to ignore. Its moons are just as extraordinary as the planet itself. Some hide oceans beneath frozen shells. Others preserve scars from collisions that happened billions of years ago. And some remain so small and distant that humanity has barely begun to understand them. Our next destination is Suttungr, a tiny irregular moon discovered in the early 21st century. Measuring only a few kilometers across, it is almost insignificant compared to Saturn's largest satellites. Yet size has never determined importance in the universe. Suttungr follows a distant retrograde orbit. Unlike Saturn's major moons, it travels around the planet in the opposite direction. This unusual motion immediately tells astronomers something important. Suttungr almost certainly did not form alongside Saturn. Instead, it was likely captured by the giant planet's gravity long after the solar system had already taken shape. It may once have wandered freely through deep space, until one close encounter changed its destiny forever. Many of Saturn's outer moons share similar paths. Together they form small families of captured worlds. Ancient fragments left behind from the violent era when planets were still growing. Every one of them is a surviving witness to the earliest chapters of our solar system. As our telescopes continue improving, these distant moons slowly begin revealing their secrets. Each observation brings another piece of a puzzle that has remained incomplete for billions of years. Our journey now carries us toward another small but fascinating satellite. Hyrrokkin. Discovered in 2004, Hyrrokkin is another irregular moon orbiting far beyond Saturn's magnificent rings. Its average diameter is only a few kilometers, tiny compared with the giant world surrounding it. Yet its orbit tells an extraordinary story. Like Suttungr, Hyrrokkin moves in a distant retrograde path. Everything about its motion suggests that it was captured rather than created alongside Saturn. Perhaps it once belonged to another planetary system. Perhaps it has traveled through interstellar space before finding a permanent home. For now, no one knows. Every captured moon reminds us that the solar system is not a perfectly closed family. Throughout billions of years, wandering objects have crossed its boundaries. Some continued their endless journeys. Others became permanent members of entirely new worlds. Saturn's outer moons may be among the oldest survivors of those ancient encounters, each one preserving clues from an age long before Earth became the planet we know today. As we leave these distant worlds behind, another mystery begins to emerge. Saturn's magnificent rings. Perhaps the most recognizable feature of any planet in our solar system. Beautiful, delicate, and far more fragile than they appear. Saturn's rings have fascinated humanity for centuries. Even through a small telescope, they transform Saturn into one of the most beautiful sights in the night sky. But beauty is only the beginning of their story. For generations, scientists wondered how these magnificent rings were formed. Did they appear alongside Saturn billions of years ago? Or were they created much later by a catastrophic event? Even today, the debate continues. One possibility is that a large icy moon wandered too close to Saturn. The planet's immense gravity tore it apart. Over time, the countless fragments spread into orbit, eventually forming the spectacular rings we see today. Another idea suggests that several smaller moons collided with one another. The debris remained trapped by Saturn's gravity, slowly creating the enormous ring system surrounding the planet. Whatever their true origin may be, the rings are far from permanent. Observations from the Voyager spacecraft first hinted that something unexpected was happening. Decades later, the Cassini mission confirmed it. The rings are slowly disappearing. Tiny particles of ice continuously fall towards Saturn, a process scientists call ring rain. Every second, countless fragments leave the rings forever. If this continues, the entire system could vanish within only a few 100 million years. Compared with the age of the solar system, that is only a brief moment. One day, future civilizations may look toward Saturn and see a planet with no rings at all. As astonishing as that sounds, the universe is constantly changing. Even its most beautiful creations are not eternal. Among Saturn's many moons, another world may help explain this disappearing masterpiece. Pan, a tiny moon hidden within the rings themselves. Discovered by the Cassini spacecraft, Pan orbits inside the Encke gap. As it travels around Saturn, its gravity pushes ring particles aside, keeping the gap open as it completes its endless journey. Its shape is unlike almost anything else in the solar system. Instead of being perfectly round, Pan resembles a giant flying saucer. Over billions of years, fine particles from Saturn's rings settled gently onto its surface, building a broad ridge around its equator, giving the moon its extraordinary appearance. Watching Pan move through the rings is like watching a small boat crossing a calm ocean. Except the waves are made of ice, and the ocean stretches for hundreds of thousands of kilometers. Tiny worlds like Pan reveal something extraordinary. Even the smallest objects can shape an entire planetary system. Gravity does not measure importance by size. It measures only mass and distance. And sometimes, that is enough to leave a mark lasting billions of years. Our journey through Saturn's moons is slowly coming to an end. But one final destination still awaits us. The largest moon of Saturn. A world unlike any other. Titan. Titan is unlike any other moon in the solar system. It is Saturn's largest satellite. the second largest moon known to science. Larger even than the planet Mercury. At first glance, Titan appears calm. A distant world wrapped in a thick golden haze. Its surface remains hidden beneath an atmosphere so dense that sunlight struggles to reach the ground. For centuries, no one knew what lay beneath those clouds. Only modern spacecraft finally revealed its secrets. Titan is the only moon in the solar system with a substantial atmosphere. In some ways, it resembles the young Earth billions of years ago. Its skies are filled primarily with nitrogen. Complex organic molecules drift through the atmosphere. A thick orange mist covers the entire world. Beneath those clouds lies one of the most extraordinary landscapes ever discovered. Lakes, rivers, seas, not made of water, but of liquid methane and ethane. On Titan, temperatures are so unimaginably low that water behaves like solid rock. Meanwhile, methane exists as a liquid, flowing through valleys, filling enormous lakes, even forming rain clouds above the surface. It is the only world beyond Earth where scientists have confirmed stable lakes and seas on its surface. Titan possesses its own weather cycle. Clouds form. Rain falls. Rivers carve their way across the landscape. Lakes slowly expand and disappear. Everything appears strangely familiar. Yet every liquid is made from hydrocarbons instead of water. Far beneath Titan's frozen crust, scientists believe another extraordinary feature may exist. A vast underground ocean of liquid water, completely hidden beneath kilometers of solid ice. If such an ocean truly exists, Titan immediately becomes one of the most promising places to search for extraterrestrial life. Not because life has been found there, but because the ingredients needed for chemistry are already present. Organic molecules, liquid reservoirs, energy from Saturn's powerful gravitational influence. Together they create possibilities unlike almost anywhere else in the solar system. Future missions hope to explore Titan more closely than ever before. One of them is Dragonfly, a nuclear-powered flying laboratory designed to travel from one location to another across Titan's surface. Unlike traditional rovers, Dragonfly will fly through Titan's dense atmosphere, landing in multiple regions, studying the chemistry of this extraordinary world from many different locations. Scientists hope it will answer one of humanity's oldest questions. Can the building blocks of life exist beyond Earth? Perhaps Titan already holds the answer. For now, it remains hidden beneath its endless orange sky, patiently waiting, silently preserving secrets that have survived since the birth of the solar system. As we leave Titan behind, another remarkable world waits in the darkness. Enceladus. At first glance, it appears to be nothing more than a small frozen moon. Bright, silent, almost perfectly white. Yet beneath that frozen exterior lies one of the greatest discoveries ever made in planetary science. Enceladus measures only about 500 kilometers across. Compared with Earth's moon, it is incredibly small. But size has never determined importance. Its surface reflects almost every ray of sunlight that reaches it. Fresh ice constantly renews the landscape, making Enceladus one of the brightest objects in the entire solar system. For many years, scientists believed it was simply another frozen world. Then everything changed. When the Cassini spacecraft flew past Enceladus, it detected enormous plumes erupting from its south pole. Towering jets of water vapor, ice particles, organic compounds, all escaping through gigantic fractures in the frozen crust. Those discoveries transformed our understanding of this tiny moon. Beneath kilometers of solid ice lies a vast global ocean. An ocean kept liquid by powerful tidal forces generated by Saturn's gravity. Every orbit gently stretches and compresses the moon, creating enough heat to prevent the water below from freezing completely. Even more astonishing, Cassini detected hydrogen molecules within those plumes. On Earth, similar hydrogen is often produced around hydrothermal vents on the ocean floor, places where some of the planet's most primitive life forms survive without sunlight. That discovery immediately placed Enceladus among the most promising locations in the search for extraterrestrial life. No evidence of life has been found, but nearly every ingredient scientists consider important appears to exist. Liquid water, organic molecules, energy. Three ingredients that continue to fuel one of the greatest scientific investigations of our time. Every eruption from Enceladus throws material into space. Some of those frozen particles eventually become part of Saturn's faint E-ring, meaning this tiny moon is continuously reshaping its surroundings. Even now, billions of years after its formation, Enceladus reminds us that life may not require warm sunlight or Earth-like conditions. Sometimes, the most extraordinary possibilities are hidden beneath layers of ancient ice. Our journey through Saturn's remarkable family is not over yet. Another extraordinary moon is waiting beyond the frozen darkness. Iapetus. Discovered in 1671 by Giovanni Domenico Cassini, Iapetus immediately puzzled astronomers. Sometimes it appeared bright. At other times, it almost vanished completely. For centuries, no one understood why. The answer would eventually become one of the strangest discoveries ever made. One side of Iapetus is almost as dark as coal. The other is covered in brilliant ice that reflects sunlight with remarkable intensity. The contrast is so dramatic that the moon appears to have two completely different faces. No other large moon in the solar system looks quite like it. Scientists believe dark material from distant outer moons slowly settled across one hemisphere. As that surface absorbed more sunlight, its ice gradually evaporated. The brighter hemisphere remained frozen. Over millions of years, the difference became even more extreme. But Iapetus holds another mystery. Running almost perfectly along its equator is a gigantic mountain ridge. Some sections rise more than 20 kilometers above the surrounding plains, making it taller than nearly every mountain on Earth. No one knows exactly how this enormous ridge formed. Some researchers believe Iapetus may once have possessed its own ring system. As those rings slowly collapsed, the material settled along the equator, creating the immense wall that still circles much of the Moon today. Others suggest powerful internal activity shaped the surface long ago. For now, the mystery remains unsolved. Every answer seems to create another question. Epimetheus reminds us that even after centuries of observation, the solar system continues to surprise us. Beyond Saturn, an even greater giant now awaits. The largest planet ever formed around our Sun. Jupiter. A world so enormous that more than 1,000 Earths could fit inside it. And surrounding this giant are dozens of extraordinary moons. Some larger than planets. Some hiding oceans beneath frozen crusts. Some may even offer the best chance of discovering life beyond Earth. Our journey is only becoming more extraordinary. Jupiter is the largest planet in our solar system. A giant so enormous that more than 1,000 Earths could fit inside it. For billions of years, its immense gravity has shaped the architecture of the solar system itself. Asteroids, comets, even entire moons have had their paths altered by Jupiter's powerful gravitational pull. Surrounding this colossal world is an extraordinary family of natural satellites. Some are small captured asteroids. Others are worlds so large they rival planets. Our first destination is Europa. At first glance, Europa appears calm. Its smooth, icy surface reflects sunlight like polished glass. Unlike many moons covered with impact craters, Europa is remarkably young. Very few scars remain on its frozen shell. Something is constantly renewing its surface. Scientists believe the explanation lies beneath the ice. Hidden below a crust that may be only a few tens of kilometers thick is a global ocean. An ocean containing more liquid water than all of Earth's oceans combined. That single discovery transformed Europa into one of the most important worlds in modern astronomy. The ocean is believed to remain liquid because of Jupiter's gravity. As Europa travels around the giant planet, powerful tidal forces continuously stretch and compress the Moon. The resulting friction generates heat deep inside its interior, enough to prevent the hidden ocean from freezing solid. Some estimates suggest this ocean could be more than 100 kilometers deep, far deeper than any ocean on Earth. If that is true, Europa may contain one of the largest reservoirs of liquid water anywhere in the solar system. The question scientists continue asking is both simple and profound. Could life exist there? No evidence has been found. But liquid water, organic chemistry, and internal energy may all exist together beneath the frozen surface. Those ingredients make Europa one of humanity's greatest scientific priorities. Future missions are already preparing to investigate this extraordinary world. The Europa Clipper spacecraft will perform dozens of close flybys, carefully studying the Moon's icy crust, searching for signs of underground water, and identifying places where future missions might one day search directly for evidence of life. Beneath that silent frozen shell, an entire ocean has remained hidden for billions of years. Waiting. Not for civilization. Not for history. But simply for someone to discover that it exists. Europa reminds us that the universe often hides its greatest wonders beneath the most ordinary appearances. And Jupiter still has even more extraordinary worlds waiting ahead. Our next destination is Callisto, the most heavily cratered world in the entire solar system. At first glance, it appears ancient. A silent landscape where almost nothing has changed for billions of years. Unlike Europa or Ganymede, Callisto shows very little evidence of internal activity. Its surface has preserved the scars of countless impacts since the earliest days of the solar system. Every crater tells the story of an ancient collision. Some are small. Others stretch across hundreds of kilometers. Together they create one of the oldest surviving landscapes known to science. Yet beneath this seemingly lifeless world, another mystery may be waiting. Measurements collected by spacecraft suggest that a vast underground ocean could exist beneath its frozen crust. If confirmed, Callisto would become another ocean world orbiting Jupiter. Unlike Europa, however, Callisto experiences far weaker tidal forces. Its interior appears far more stable, far quieter. Even so, liquid water may still survive beneath kilometers of ancient ice. Scientists continue studying this possibility with great interest. Not because Callisto seems active, but because it has remained almost untouched since the solar system was born. It is a natural archive, a world preserving information that many other planets and moons have long since lost. Future missions may eventually explore Callisto in far greater detail. Some researchers have even proposed that it could serve as a staging point for future human expeditions deeper into Jupiter's system. Its radiation environment is much less intense than that surrounding Europa or Io, making it one of the safest locations near Jupiter. Callisto reminds us that silence does not always mean emptiness. Sometimes the oldest worlds preserve the greatest stories. And while Callisto appears frozen in time, another moon nearby could not be more different. A world shaped by constant violence, relentless heat, and unstoppable volcanic power. Io. Io is the most volcanically active world ever discovered. Nothing else in the solar system compares to it. While many moons have become quiet over billions of years, Io remains in a constant state of change. Its surface is continually reshaped by enormous volcanic eruptions. Mountains rise. Lava flows across the landscape. New plains form while older ones disappear beneath fresh layers of molten rock. More than 400 active volcanoes have already been identified. Some produce eruptions powerful enough to send material hundreds of kilometers above the surface. From space, Io appears unlike any other world. Brilliant shades of yellow, orange, red, black, and white cover its landscape. These remarkable colors are created by sulfur and sulfur compounds released during volcanic eruptions. The result is a world that looks almost unreal. A place where fire never truly rests. The source of this extraordinary activity is Jupiter itself. As Io moves around the giant planet, its orbit is constantly influenced by Europa and Ganymede. Those gravitational forces gently pull and stretch the Moon during every orbit. Deep inside, enormous friction is produced. That friction generates enough heat to keep much of Io's interior molten. It is a process known as tidal heating. Without it, Io would likely have become another cold and inactive moon billions of years ago. Instead, it remains one of the most dynamic places in the solar system. Its atmosphere is extremely thin, composed mainly of sulfur dioxide released by its volcanoes. When Io passes into Jupiter's shadow, temperatures fall rapidly. Much of that atmosphere freezes onto the surface. As sunlight returns, it slowly forms once again. Every orbit begins the same cycle. Heat, cooling, freezing, renewal. Radiation surrounding Io is among the most intense anywhere in the solar system. A human standing on its surface would receive a fatal dose within a very short time. For that reason, exploring Io remains one of the greatest engineering challenges in planetary science. Yet despite its hostile environment, Io continues attracting scientists from around the world. Every eruption offers another opportunity to understand how planets and moons release their internal heat. Io reminds us that even after billions of years, some worlds are still being created before our eyes. As we leave this extraordinary moon behind, our journey through Jupiter's family continues. Another remarkable world is waiting beyond the giant planet. One whose frozen surface may hide secrets just as extraordinary as those beneath Europa. Beyond Io, Jupiter still holds another remarkable world. Amalthea. Unlike the large spherical moons we have already explored, Amalthea is small and irregular. Its elongated shape immediately reveals that gravity was never strong enough to pull it into a perfect sphere. Discovered in 1892 by Edward Emerson Barnard, it became the last natural satellite found through direct observation with a telescope before the age of spacecraft. Amalthea orbits astonishingly close to Jupiter, completing one full orbit in less than 12 hours. From its surface, Jupiter would dominate the sky, appearing hundreds of times larger than the Moon appears from Earth. The giant planet would never seem to set. It would remain suspended above the horizon almost constantly. Scientists believe Amalthea is composed largely of porous rock mixed with significant amounts of ice. That discovery surprised researchers. At such a close distance from Jupiter, temperatures should have driven most of the ice away billions of years ago. Its low density suggests that the Moon may have formed farther from Jupiter before gradually migrating inward. Or perhaps it originated under conditions we still do not fully understand. Its ancient surface is covered with enormous impact craters. Some are so large they occupy a significant portion of the Moon itself. Towering cliffs and deep valleys reveal a world shaped by violent collisions throughout its history. Although Amalthea is small, it plays an important role within Jupiter's system. Tiny particles escaping from its surface contribute to Jupiter's faint ring system. Even this modest moon continues influencing the giant planet that surrounds it. Every moon we encounter reminds us that the solar system is a place of endless variety. No two worlds share exactly the same story. No two journeys are identical. And as we leave Jupiter behind, another destination begins to emerge from the darkness. Mars. A smaller world, yet one accompanied by two mysterious moons whose origins continue to challenge astronomers. Mars may be far smaller than Jupiter or Saturn, yet its two tiny moons have puzzled astronomers ever since their discovery. Phobos and Deimos. Unlike the large, nearly spherical moons of the giant planets, these two worlds are small, dark, and irregularly shaped. At first glance, they resemble asteroids more than natural satellites. That similarity has led many scientists to believe they were once wandering objects captured by Mars long ago. Others suggest they may have formed from debris thrown into orbit after a massive impact on the young planet. Even today, their true origin remains uncertain. Our first destination is Phobos, the larger of Mars' two moons. Discovered in 1877 by American astronomer Asaph Hall, Phobos measures only about 22 kilometers across. Despite its small size, it orbits incredibly close to Mars. So close that it circles the planet in less than 8 hours. That means Phobos rises in the west and sets in the east. The opposite of what we experience on Earth. Anyone standing on the Martian surface would see this strange moon racing across the sky more than once each day. Its surface is covered with impact craters. The largest, Stickney crater, stretches across nearly half the width of the moon itself. The collision that created it almost shattered Phobos completely. Long fractures spread outward across its surface. Silent evidence of one of the most violent impacts in its history. But the greatest mystery surrounding Phobos is not found on its surface. It is found in its future. Unlike Earth's moon, which slowly moves farther away, Phobos is gradually spiraling inward. Every century it moves several meters closer to Mars. The planet's gravity is slowly pulling it toward an unavoidable fate. Scientists estimate that within the next 30 to 50 million years, Phobos will either crash into Mars or be torn apart by the planet's tidal forces. If it breaks apart first, the fragments could briefly form a spectacular ring around Mars. A ring unlike anything the planet has ever possessed. Even the skies of entire planets continue changing over time. Nothing in the universe remains exactly the same forever. As Phobos slowly approaches its destiny, one final moon still waits for us. A quieter companion traveling much farther from Mars. Deimos. Our final destination is Deimos, the smaller and more distant of Mars' two natural satellites. At first glance, it hardly resembles a moon at all. Its irregular shape and dark surface make it look more like a wandering asteroid captured long ago. Scientists still debate its true origin. Some believe Deimos was once an asteroid drifting through the asteroid belt. Later, Mars' gravity may have captured it, turning it into a permanent companion. Others suggest it formed from debris left behind after a massive collision early in the planet's history. For now, neither explanation has been confirmed. Deimos measures only about 12 kilometers across. Its tiny size gives it an extremely weak gravitational pull. Too weak to retain a meaningful atmosphere. As a result, its surface has remained exposed to the harsh environment of space for billions of years. Layers of fine dust cover much of the Moon, softening the appearance of many impact craters. Compared with Phobos, its surface is noticeably smoother. Its largest known craters are Swift and Voltaire, both serving as silent reminders of ancient collisions that shaped this tiny world. Unlike Phobos, Deimos follows a much more distant orbit around Mars. It completes one journey around the planet in approximately 30 hours. To an observer standing on the Martian surface, Deimos would appear almost like a bright star moving slowly across the sky. Its gentle motion reflects the quiet nature of this distant companion. While Phobos is slowly spiraling toward Mars, Deimos is moving in the opposite direction. Little by little, it continues drifting farther away. According to current calculations, several million years from now, Deimos will eventually escape Mars' gravitational pull.